Did you know that as many as 1 in 4 hand pump boreholes might not be working at any given time? Um, just in sub-Saharan Africa.
Yeah, it's a pretty stark figure. It really throws the scale of the challenge into sharp relief, doesn't it?
It absolutely does. And that scale, that challenge is exactly what we're digging into today. We've
Hmm.
got the results of, well, a really fascinating recent survey, the Stop the Rot Diagnostic Survey 2024.
Right, the Stop the Rot initiative.
Exactly. And this survey really tries to get under the hood of how well these boreholes and pumps for rural water are actually performing, and crucially, what's being done to, maintain them.
And it's a key part of that broader Rural Water Supply Network initiative, RWSN's Stop the Rot. It involves the British Geological Survey, Baseflow, and Ask for Water Ltd.
So a real collaboration.
Definitely. A collaborative effort focused squarely on tackling this critical issue of underperforming water infrastructure, why things break down.
What really struck me was the breadth of who they talked to. We're looking at 111 responses representing over 88 organizations spread across 62 countries.
Yeah, it's impressive.
And these aren't just academics observing from afar. These are the people actually involved. NGOs, the private sector, funding bodies, UN agencies, researchers. It's a really diverse group.
And that diversity, I think, is what makes the findings so valuable. It gives us this kind of panoramic view,
Mm,
highlighting the common problems, but also where different people might see things slightly differently.
right. So, for you listening, our aim today is to really cut through the noise and get to the heart of why these vital water systems often struggle. What are the core problems? What solutions might be emerging?
You think of it as an informed shortcut, maybe.
Yeah, exactly. A shortcut to understanding the complexities. And we'll also touch on how this survey is feeding into developing a practical guide to actually help address these very issues on the ground.
So maybe starting with who responded. It's quite revealing. The survey found a large majority, 75%, are involved with hand pumps for community use. That's still huge,
Still the mainstay in many places.
but almost as many, 68%, are now working with solar pumps for communities too.
Ah, interesting. So solar is really catching up, or at least there's significant activity there.
It seems that way, yes. The interest is definitely growing. And what's more, about two-thirds, 66%, are actually involved with both hand pumps and solar for community systems.
Which suggests a kind of pragmatic approach, right? Using the best tool for the job depending on the context.
Exactly. It probably reflects the different environments, the resources available where these organizations work.
Makes sense.
And their roles are varied too. The survey showed respondents are active right across the project lifecycle.
From funding all the way to drilling.
Yep. Funding, managing contracts, the direct work of drilling, installing, rehabilitation, and importantly, supporting the ongoing management and maintenance.
Wow.
In fact, quite a chunk, 44%, are involved in all three major stages: funding, contracting, and implementation.
So they really see the whole picture, from the money side to the muddy boots side.
Precisely. They have this holistic view of what works and, perhaps more importantly, what doesn't.
Which leads us nicely into monitoring, doesn't it? Checking up on these systems after they're built. Post-construction monitoring, how important do people think that is?
Well, there's almost universal agreement there. An overwhelming 93% considered it either important or extremely important.
Okay, so pretty much everyone agrees it should be done.
Fundamentally, yes.
Yeah.
There's a clear understanding that just building the thing is only step one. Making sure it keeps working long term, that's vital.
And are they actually doing it? Is the practice matching the principle?
To some extent. The encouraging part is that a big majority, somewhere between 74% and 82%, say they undertake or commission this monitoring at least sometimes.
At least sometimes. Okay, that sounds a bit qualified.
Exactly, and this is where it gets nuanced. When the survey dug deeper into what monitoring actually means in practice, well, it varies a lot. For one thing, it often includes checks during construction, which is good for quality control, obviously.
Sure, essential.
But the post-construction stuff, it ranges hugely from, say, weekly checks in some projects to much broader impact evaluations, maybe 5 years down the line.
Right, so it's not one standard activity. Monitoring can mean very different things.
Very different. And the focus of that monitoring differs too.
Yeah.
Some might be looking mainly at the social side. How's the community management going? Is the committee active?
Okay, the human element.
Others are more focused on the technical bits, the pump itself, the borehole condition. And then you have people tracking Physical things like water levels, which is becoming more critical with climate change,
Hmm.
or even broader environmental factors are on the water point.
It shows how interlinked it all is, I suppose. A great pump won't last if the community can't manage it, or if the water source itself dries up.
You've hit the nail on the head.
Yeah.
All these pieces need attention for a system to be truly sustainable.
Okay, so monitoring is seen as crucial. It happens in various forms, but systems still fail a lot. What did the survey find were the main reasons? The key culprits for poor performance or outright failure?
The rot in stop to rot. The survey really unpacked this, grouping the causes. On the social side, things like poor community leadership or management came up frequently.
Right, the classic challenges.
Yes. Also, a lack of robust, long-term sustainability plans. If there's no plan for repairs or part replacement.
It's bound to fail eventually.
Exactly.
Hmm.
Affordability for users is another big one. If people can't afford the upkeep, even if it's minimal.
Then it won't happen.
Right. High turnover in those watch committees was mentioned too, losing experience and continuity. And sometimes it goes right back to the start. A failure to do a proper needs assessment, leading to the wrong kind of system being installed in the first place.
That makes so much sense. If it doesn't fit the community's needs or capacity from day one, it's set up to struggle. What about the physical side? Water levels, things like that.
Key issues there included concerns about inaccurate reporting of initial flow rates.
So maybe the borehole wasn't as productive as claimed.
Potentially, yes, setting unrealistic expectations. And the impact of climate change was definitely noted: insufficient water yield in the dry season, dropping water tables generally. Those were significant concerns.
These physical limits really highlight the pressure on water resources. Okay, let's get technical. What about the pumps and pipes themselves? Hand pumps first.
For hand pumps, a major theme was substandard materials and parts, just poor quality components failing prematurely.
Cutting corners, perhaps?
It could be, or just lack of good supply chains. Corrosion was a big one too, especially corrosion of pipes and rods. They specifically mentioned galvanized iron pipes in Zimbabwe causing real problems.
Ah, GI pipes. They can be prone to that, can't they?
Very much so, depending on the water chemistry. Other technical issues: broken riser pipes, the pipes go down the borehole, pumps simply installed incorrectly in the first place, and the old chestnut, lack of readily available spare parts. Still a huge issue.
It's frustrating that basics, like using the right materials or installing things properly, are still major hurdles. What about the solar systems? They're newer, maybe fewer problems.
Well, yes and no. Interestingly, some respondents felt solar pumps might actually be more durable overall.
Oh, really?
But they have their own vulnerabilities. Things like power outages affecting systems without enough battery backup.
Even solar needs reliable power, in a sense.
Right. Or boreholes that were okay for a hand pump, just not yielding enough water for a more demanding solar pump. Inadequate borehole standards for solar.
Ah, you need more water for those.
Generally, yes. Then there's the quality of the components. Poor quality panels, batteries, controllers failing. Installation errors came up too. Things like bad cable splicing, not installing sensors to stop the pump running dry.
Simple things that cause big failures.
Exactly. And even basic plumbing issues like leaks in storage tanks or valves. So solar has advantages, definitely, but it needs specific skills and good quality parts to be reliable.
So different technologies, different headaches, and it's not just the pump, is it? The borehole itself can be the problem.
Absolutely critical. Poor borehole completion. Maybe the drilling wasn't finished properly.
Mhm.
Boreholes without proper casing, so they might collapse. A lack of sanitary seals at the top to prevent contamination getting in.
That sounds dangerous.
It can be. And even instances of falsified pump test results suggesting the borehole was better than it really was. And we can't ignore the immediate surroundings. Poor hygiene, mud, maybe toilets too close. They can contaminate the water right at the source.
It's a whole system that needs to work. The survey also picked up on some sort of accepted wisdom or common perceptions among the respondents, didn't it?
Yes, box 1 in the report captures those. Like the idea that solar pumps might last longer but need more technical skill to fix, whereas hand pumps might break more often but are, supposedly easier for local mechanics to handle.
The trade-offs.
Exactly. And another interesting contrast was the perception between privately owned pumps, which often get well looked after, and community pumps, where that sense of ownership and responsibility for maintenance can be, well, a bit more diffuse or challenging.
That ownership question keeps coming up, and the survey also touched on sort of deeper systemic issues.
It did. Things like the challenges with traditional community management models. Are they always the best fit? A lack of a strong embedded maintenance culture in some places, Even the basic design limitations of certain hand pump models were flagged as contributing factors.
Okay, so we have a clearer picture of the problems. Let's shift back to monitoring. What is being done? What kinds of monitoring activities are actually happening?
Well, as we said, the frequency is all over the place. Some do weekly checks, others quarterly, 6-monthly, biannually. Some just check after a couple of years, and then you have those 5-year impact evaluations.
And they're monitoring all sorts of water points.
Pretty much everything. Hand pumps, solar, motorized electric boreholes, even hybrid systems. And in all sorts of places, communities, sure, but also private homes, schools, clinics, even displacement camps.
So the need for oversight is recognized across the board.
It seems so, yes.
You mentioned tools earlier, things like M-Water being used. How's tech fitting in?
Yeah, M-Water is a good example of a digital platform organizations are using to actually record and manage the data they collect during monitoring.
Makes it easier than paper forms, I imagine.
Definitely.
Yeah.
And one respondent specifically said they use the performance data they collect in M-Water to help decide which drilling contractors to use in the future.
Ah, using the data for accountability?
Exactly. If the data shows consistently poor performance from one contractor's work, well, that's valuable information.
That seems like a really positive step, using data to drive quality. But
Yeah.
if monitoring is so important, why isn't it happening more consistently everywhere? What holds organizations back?
Good question. The survey asked that directly. Interestingly, the most common reason given for not funding or doing post-construction monitoring was
Lack of money.
not primarily, no. It was the view that it's the responsibility of the local or national government. That came from 35% of respondents.
Okay, so passing the responsibility in a way, or assuming someone else is handling it.
Or perhaps reflecting where they believe the long-term responsibility should lie. But yes, it highlights the expected role of government.
But if the government isn't always able to step up, who else is involved?
Well, the survey did show communities themselves doing monitoring in about 26% of cases, and the local private sector in 22%. So there is some distribution of that role.
A more mixed model.
Potentially.
Yeah.
But funding is still a major constraint, absolutely, and aligning activities with donor priorities. If post-construction monitoring isn't something a donor specifically asks for or funds, it often falls down the priority list.
Right. The funding reality bites. Okay, let's talk practicalities. When a pump breaks down, are people using standard checklists or procedures to figure out what's wrong?
Surprisingly, perhaps, less than half are. Only 49% of respondents said they use a specific protocol or checklist for diagnosing failures.
Less than half. Wow, that seems low. Why not?
Several reasons came up. Some just hadn't thought about it or didn't see it as a priority. Others weren't aware such tools even existed. And the familiar constraints, lack of time, staff capacity, or the resources to develop their own checklist.
Which really highlights the need for the kind of guidance the Stop the Rot initiative is working on, doesn't it?
Absolutely. It suggests a real appetite for practical, ready-made tools to help standardize troubleshooting.
Did the survey find examples of good checklists being used? What do they cover?
Yes. Among the 49% who do use them, the scope varies. Some are purely technical pump, borehole issues. Others are broader, including social or community management aspects.
Right, covering the whole system again.
Exactly. And some mentioned using M-Water again, this time for collecting data as part of the diagnostic process. People also referenced external resources, like the SADC groundwater manual or WHO guidelines, so they're drawing on existing knowledge.
So good practice exists, but it's patchy. Another term that came up was sanitary inspection. What did respondents understand that to mean?
That was another area where understanding seemed quite varied. About 70% said they undertake these inspections,
Okay.
but what they meant by it differed. Some linked it to general sanitation, building toilets, or CLTS activities. Others thought primarily about water quality testing.
But the survey intended something more specific.
Yes, the intended focus was really on the immediate physical environment around the water point. Is the concrete apron intact? Is there proper drainage? Is the seal at the top of the borehole visible and intact? Are there sources of contamination nearby, like latrines or animal waste?
Because even a working pump is no good if the water gets contaminated right there.
Precisely. It's about protecting the water source itself. So there seems to be a need for a clearer, shared definition of what a sanitary inspection entails in this context.
Makes sense. Again, maybe something guidance can help with.
Some organizations did mention using WHO guides, like the Small-Scale Water Supply System Guide or the Sanitary Package, which do provide frameworks for this, but again, not universally adopted or maybe understood in the same way.
Okay, we've looked at the problems, the practices, the gaps. What do the organizations themselves say they need? What would help them improve their monitoring and diagnostic work?
The survey asked them directly. And the number one need, by far, guidance documents.
Uh-huh. Validation for a stop the rot goal.
Absolutely. It strongly reinforces that objective. But it wasn't just documents. They also stressed the need for more training, for capacity strengthening for their staff, and for better ways to learn from each other, sharing experiences and best practices across the sector.
Learning from peers.
Exactly. And of course, the perennial issue, dedicated funding to actually support all these activities.
Funding always comes up. The report annex also had some really concrete suggestions, didn't it? What kind of practical help are people asking for?
Oh yeah, Annex 2 is full of really specific practical ideas.
Mm-hmm.
Things like standardized repair protocols for common pump types, updated life cycle cost sheets so you can actually budget for maintenance realistically.
Knowing the true cost over time.
Right. Setting up instant communication links between communities and technicians. Maybe using mobile tech to report breakdowns faster. Pre-designed diagnostic checklists that people could just pick up and use.
Making it easy to do the right thing.
Yes. Some even suggest making post-construction monitoring mandatory for all water projects.
A bolder step. Any other standouts?
Lots. Up-to-date maintenance manuals for specific pump models, contact lists for reliable spare parts suppliers, that's a huge practical need, access to low-cost, reliable water meters.
For better usage monitoring.
Exactly. Strengthening local staff skills in troubleshooting, maybe establishing regional pump repair centers, developing failure manuals like guides to common problems and how to fix them, training local borehole caretakers to be basic technicians, better community engagement strategy,
Now empowering the community.
integrating technology more effectively for monitoring, better access to qualified local technicians, not always relying on people from far away, guidance on securing long-term funding, the Holy Grail, and finally, properly integrating environmental and climate change considerations into everything.
Wow, that is a comprehensive wish list. But it all sounds incredibly practical and based on real experience.
It really does. It shows the depth of thinking on the ground about what's needed to move beyond just building things towards actually ensuring they provide reliable service long term.
And it seems these organizations aren't just asking for help, they're willing to chip in too, in developing the guidance, for instance.
Yes, absolutely. The interest level was really high. 76% said they were directly interested in supporting the development of the plan guidance.
That's fantastic engagement.
And another 18% said they might be interested. So huge potential for collaboration there, which is crucial to make sure the guidance is useful, relevant, and actually gets adopted.
So as we bring this deep dive into the Stop the Rot survey to a close, what are the big takeaways for our listeners? What should they really remember?
Well, I think the survey really hammers home that while everyone agrees post-construction monitoring is vital for rural water supplies, the reality on the ground is, well, it's inconsistent. It faces real challenges.
The gap between principle and practice.
Precisely. There's a clear need for better diagnostic tools, for standardized approaches to maintenance and repair, and maybe a clearer shared understanding of basic protective measures like sanitary inspections.
And underlying all that.
Underlying it all, the survey really highlights the critical importance of genuine community involvement, finding sustainable funding streams, providing targeted training, and building robust local capacity. Without those pieces, the technical fixes often won't last.
And understanding all these interconnected bits. The technical, the social, the money side, the skills. It's just crucial, isn't it, for anyone involved in or even just interested in global development, public health, sustainable solutions.
Absolutely. It's complex, no doubt about it. But we need to grasp that complexity if we want to make a real dent in those, frankly, unacceptable failure rates that 1 in 4 statistic we started with.
Which brings us to a final thought, maybe something for you listening to ponder.
Given that we're seeing this increasing reliance on groundwater and solar pumping is becoming so much more popular, how do we make sure we actually learn from the decades of sometimes painful experience with hand pumps?
Good question.
How do we apply those lessons proactively to these newer technologies? How do we build in that robust monitoring, that maintenance planning right from the start so we genuinely prevent the rot this time around and ensure these vital resources are sustainable for the long haul?
A really critical point to consider for the future. And if this discussion has sparked your interest and you want to explore further, we definitely recommend checking out the Rural Water Supply Network, RWSN, and the Stop the Rot initiative specifically.
Yes, lots more information available there on their ongoing work and how people are tackling these challenges.